Classification. Classification is a type of supervised machine learning task where the goal is to assign predefined labels or categories to input data based on its characteristics. The algorithm learns from a label training dataset where each input is associated with a known output or class. The objective is to build a model that can generalize to correctly classify unseen or new instances into the predefined classes. Logistic regression. Logistic regression is a statistical method used for binary classification tasks where the outcome variable is categorical and has two classes. Despite its name, logistic regression is used for classification, not regression. It models the probability that a given instance belongs to a particular category. The output expected from a logistic regression is a probability score between 0 and 1, indicating the likelihood of the instance belonging to the positive class. To convert this probability score into a class prediction, a threshold is chosen. Usually, the threshold will be 0.5. If the probability is above the threshold, the instance is predicted to belong to the positive class, otherwise, it is predicted to belong to the negative class. Decision trees. A decision tree is a supervised machine learning algorithm used for both classification and regression tasks. It works by recursively partitioning the dataset into subsets based on the values of its input features. At each step, the decision tree algorithm selects the feature that provides the best split, making decisions in a tree-like structure until a stopping criterion is met. The output expected from a classification task would be a decision tree is a predicted class label for a given set of input features. For regression tasks, the output is a continuous numerical value. In both cases, the output is obtained by traversing the tree from the root to the leaf node based on feature values of the input instance. So here you might have a doubt that it has been stated that decision tree is used for both classification and regression tasks. But why the decision tree is coming under classification? That is because decision tree is mostly used for classification tasks. So since the comparativeness is giving a most positive results towards the classification task, the decision tree goes towards the classification. And if you have to see how decision tree works, so there's a decision node and there are branches, and finally we get the leaves from which we receive the results. Next, you should understand the important concept that is called ensembling. Ensembling is a machine learning technique that involves combining the predictions of multiple models to produce a more robust and accurate prediction than any individual model. The idea behind ensembling is that by aggregating the insights of multiple models, the weakness of one model can be compensated for by strengths of others, leading to improved overall performance. So there are two main types of ensembling methods. First one is bagging. Bagging involves training multiple instances of the same base model on different subsets of training data, typically obtained through bootstrap sampling. Each model is trained independently, and boosting focuses on training multiple weak models sequentially, where each subsequent model corrects the errors of the previous ones. The weight of each instance is the dataset. In the dataset, it's adjusted during the training based on its classification error. So to give more context here, bagging is like you get results from different models and you get the average, whereas boosting is like you sequentially get the results from different models. Random forest. Random forest is an ensemble learning technique that builds multiple decision trees during training and outputs the mode or average prediction of the individual trees. The output from a random forest depends on the task it is applied to. If it is a classification task, the output is the mode of the individual tree predictions. If it is a regression task, The output is the average of the individual tree predictions.